So up to this point, we've used a diode to make a simple switch to make something like a true bypass. Then we put a signal generator on it and it became a tremolo. But what happens when you start turning that low frequency oscillator into something else? What happens when it starts approaching audio frequencies? Well, it stops being a tremolo and it becomes something else when the audio signal and the oscillator start interacting with each other. It produces these other sideband frequencies, and we get into the territory that sounds something like a ring modulator. Okay, quick disclaimer for the mathematical purists. Mathematically, this isn't a ring modulator. I know amplitude modulation and ring modulation are two different things. But at this point, it's technically close enough that it's just worth listening to what a simple diode can do. Back to the bench. When it stops acting like a tremolo, we start hearing something with new tones. Let's take a look on the bench. So back here on the bench, I still have my diode switch and inverting amplifier hooked up, but I have a couple of other things here. First of all, I've replaced the signal generator. So I made another low-frequency oscillator using the help of Craig Anderton's Electronic Projects for Musicians book that I got back in the 80s. And I borrowed a piece of the circuit from his Project 21, the phase shifter. I took the LFO circuit out of that schematic and I made a couple of changes. So here is my modified LFO. I removed a resistor so that the offset could be fully above the ground. I used a combination of resistors to get 14.7K as opposed to 15K that he originally had. And there were some other resistor choices that got me close to what was in his original schematic, but I chose these for convenience. Most importantly, I changed out this 10 microfarad capacitor with 1 microfarad so I could push the oscillations all the way up into the audio spectrum. So that's what this section in the breadboard is all about. I've also added my hardware bypass switch and my 20 dB boost. So the audio signal from the guitar is going to get boosted and then it'll interact with the LFO circuit here. The amplitude of this is high enough that I needed to boost the guitar signal so that they would interact properly to give us the right effect. So here is my clean signal. You can see my green LED here letting me know that the guitar signal is coming straight through and off to the amp. Okay, so there's my clean tone. Sounds like crap, doesn't it? So there it is. It's a pretty ugly effect, but it's kind of cool. It's like this bass ring modulator. It's pretty weird and kind of shoegaze. Anyway, I like it, but it's not the cleanest circuit in the world. I know there's plenty of better ways to build an amplitude modulator. The fact that I did this with just one diode and an LFO that was turned up to warp 6. Not the cleanest way to get the effect, but it did work, and that's kind of cool. And there's something cool about doing something with just the absolute minimum number of parts. So where I'm going with this next is I'm going to clean up the design and build up the 4-quadrant multiplier. And this can be used for ring modulation, which is important for radio broadcast again, but there's something else that a ring modulator circuit can do that starts getting towards another project that I want to work on. That other project uses solid-state devices like this to mimic the behavior or the interaction that a guitar signal has going through one of these things. That's right, solid state mimicking the behavior of a triode. So that's a little peek into the future of what I've got coming. Anyway, that's what I got. I'm happy to have shared this thing with you. It was kind of weird. I almost didn't film it, but I figured why not? I've come this far, and it's a good segue into what's coming next. All right, check you guys later.